Dear students, this is the continuation of the previous video. Now you see, what is cryptography? Cryptography is the art and science of achieving security by encoding message to make them non-readable. Okay. You see, what is encryption? What is decryption? Encryption is nothing but we have to find the cyber text from the given plain text, okay, by using this public key E modulo n. N is nothing but the product of P and Q. Here P and Q are prime numbers. Okay. What is decryption? Decryption is nothing but we have to find the plain text. That is means actually what is the real text. We have to find the real message from the cyber text. Okay. And what is D? D is the private key. Okay. So this is encryption, this is decryption. Okay. Now here first we are going to see the encryption in detail. Okay. Now what is data encryption? The action of discussing information so that it can be recovered easily by the persons who have the key, but is highly resistant to recovery by persons who do not have the key. Okay. Now what is encryption? Encryption is the process of transforming information using an algorithm called cipher to make it unreadable to anyone except those possessing special knowledge, usually referred to as a key. Okay. That is called encryption. Okay. Now here, what are the parameters in encryption? See, R is a encryption. Now see, these three are first letter of three mathematicians who created this encryption. Okay. Now that's why we are giving the name RSA encryption. Okay. Now to find the cipher text. Okay. To find the cipher text. See here, what is M? M is the plain text, the actual text. What is E? E is the key. Okay. E is the key. So now M, the plain text, the M to the power E modulo N will give the cipher text. Okay, that is the encrypted text, which is not possible to read by all, but is possible to read by only those who have the key E. Okay, if they know the key, then they can read that encrypted value. Okay, now here, what is the alphabet? What is the numerical value of the alphabet? 0. Then for B, 1. Or you can write 0, 1. C, 0, 2. D, 0, 3. E, 0, 4. F, 5. Similarly, till Z we can give the values. So, A if starts with 0, then what is that? Is 25 because the total alphabets are 26. Okay. Now, here the simple picture will explain more what is encryption. You see here, encryption is a process in which a plain text is transformed into a cipher text by the use of a key. Okay. Decryption is the reverse process. Okay. So now first we are going to see the first process which is called encryption. Now see, suppose I have plain text, then by using the key and applying the encryption algorithm, I can find the cipher text, which is not possible to read by everybody. Okay, this is the encrypted text. Okay, that's what we are going to find now. You see the example. Okay, encrypt the message STOP, encrypt the message stop, using this RSA crypto system with P and Q. P is 43 and Q is 59. Okay, and the key is 13. Okay, now actual text message is STOP stop. Now we are going to encrypt. This message by using this P value, Q value, and the key 13. Okay, So now if P and Q is given, how to find N? N is nothing but P multiply Q. That is what here. N is nothing but P multiply Q. P and Q are prime. Okay. The public key is nothing but E comma N. Okay. So we have to find N. Suppose it is not given directly. Now you see here P and Q is given. So we can find N simply by multiplying P and Q. Okay. That is N here. Okay. Now how to find the encrypted message of STOP. Okay. Now you see, first we have to check whether we can apply the RSA system for this question. Okay. For that we have to see the GCD of E comma P minus 1 multiply Q minus 1 is equal to 1. Yes, we can check now. What is E? E is 13. Okay. E is 13. Okay. What is P? 43. So P minus 1 42. What is Q? 59. So Q minus 1 is 58. So 42 multiply 58 we have to find. Then you have to check the GCD of E. GCD of 13 and the product of 43, product of 42 and 58. Definitely that is 1. Okay, it will give 1. Okay, so now we can proceed. Okay, now how to start? Because here we are going to find the ciphertext from the text message. So that here see, so that here we have the conversion from the text, from the alphabet, how to write the numeric value. Okay, so now you see here our text message is STOP. Okay, so first we have to translate into the numerical values. See, now translate STOP into the numerical value. Okay. Now, what is the value for yes? Okay, now you see this table. What is the value for yes? 18. Okay, so now 18. So now I write 18 for yes. For T, how much? 19. You see here 19. So I write here 19. Okay. What is for O? For O, 14. So I write here 14. P, what is P here? 15. So I write here 15. Okay. So now STOP is nothing but 1818191415. Okay, this is the numerical value of the text message. Okay. Now what is given here? See what we are writing, blocks of yes, because suppose you take all these 8 digits for the calculation, it is very difficult to do in the calculator. Okay, so that I am taking blocks of 4 numerical values every time, so that I take 1819 and then for the next step I take 1415. Understand what I am telling? So you cannot take all the digits one time for the calculation, because see, what is the rule here? What is the rule here for the encryption? This is the rule. Okay, see, ciphertext is equal to actual message to the power E. What is here given? 13 modulo n. N is 2537. Okay. Now you see here, what is M? M is the numerical value of the given text message. Okay, see here, what is the text message? STOP. What is the numerical value? This. See, 18191415. Suppose you write all numerical value, means all digits here for M. Suppose you write 18191415 here. How to calculate in calculator? To the power 13. Even though you apply the modular exponentiation, it is very difficult. That's why I am taking blocks of 4. It's very important. Okay, that's why I'm taking blocks of 4. Okay, so 1819 then 1415. Okay, so first I take the first block. Okay, that is 1819. Okay, now you see, what is the rule for encryption? See, this is the rule. So that here I write C is equal to m to the power E modulo 2537. Now m to the power 13 modulo 2537. M is nothing but this. M is nothing but this. All. Okay, the whole numerical value. But I am taking 1819 first time to calculate. Then second time 1415. Okay. Now you see here, for this calculation, I am using the modular exponentiation, which is explained in the previous video. Okay. So now you see, what is the first value? 1819. So now you see here, for 1819, I apply this rule. So now M is here now 1819 first. So 1819 power 13 modulo 2537. I have to calculate. See here, it is calculated, the value is, the answer is 2081. Okay, but we have to check how it is possible, how to find. Okay, now see the second value for m, that is 1415. So 1415 power 13 modulo 2537, the answer is 2182. Okay, but how? Okay, that see, the final answer is the encrypted messages, you combine this and this. Okay, that is the final answer, this is the final answer. Okay, but how? Now you see this, the following slide, you see 1819 power 13 modulo 2537 is nothing but in the form of modular exponentiation. So what I am doing, I am using modular exponentiation algorithm, which we discussed in the previous video. So now this is nothing but equal to this rule, b to the power n modulo m. So that I can write, what is b? 1819. I can write n, this is the degree 13. So now what is m? 2537. So to apply the modular exponentiation, what I want, I have to find the binary of the number n 13. So this is the binary. Okay, so I can give a0, a1, a2, a3 name from right to left. Okay, now when I apply the modular exponentiation algorithm, what I have to do, I have to assume the value of x and power initially. So what is the value of x? That is 1. What is the power? We know that rule, b modulo m. What is b here? 1819. Modulo is 2537. So see, this small number, then modulo, so this is the remainder. So this is the value of the power first. Then what you have to do, follow the steps as we did on page 3. You see here what we did in the previous video. You see like this. See this table. Like this, you have to do, see, 4 steps. You see why? Because here we have only 4 values. You see here a0, a1, a2, a3. We have only 4 values. So you have to do, see, so show all the 4 steps. Students, do this part. Yes, you have to try, you have to write for a0 what will happen. For a1 what is the x, what is power. For a2 what is x, what is power. For a3 finally you will get only the x value, that is here 2081. Understand? So like this you have to do. You see page number 3 or 4, page number 4. Okay, page number 4. Here you have to see like this, you have to calculate for a0, a1, a2, a3 what is happening, how to calculate the value. Finally you will get this value. Okay, so see here page number 3, 4. Okay, the table is given, discussed. Okay, similarly you have to do for the another part, because you see I have completed for first block, that is 1819 power 13 modulo 2537 is 2081. Okay, you have to apply the modular exponentiation. You have to do, actually you have to show that 4 steps here. Okay, similarly you have to take the second block 1415, you apply the ciphertext rule, so that see you will get this answer. Okay, but how to get? You have to do the modular exponentiation algorithm for this 1415 power 13 modulo 2537. Okay, so similarly you can means write b, n, m, then what is the binary value, then you have to apply the algorithm. You have to write here means 4 steps. Okay, from page 4. Okay, now you will find this as a value for 1415 power 13 modulo 2537 is nothing but 2182. You will get definitely. Okay, see here for a0, for a1, a2, a3 you have to do 4 steps. You have to find x and power for each value. Finally for a3 you will find only x, that is here. Okay, so now this is for the first block. See 2081 for the first block. Here for the first block what is the answer? 2081. For the second block what is the answer? 2182, which you will get by applying the modular exponentiation. So what is your final answer is nothing but you have to combine these two, that is called the encrypted message, that is 2081 2182. That is your final answer. This is your encrypted message. What is your real plain text? That is given STOP. Okay, but what is your encrypted message? 2081 2182. That's it. This is the example for calculating the encryption of the given text message. Thank you.